Hello, everyone. So today we're going to talk about, we're going to talk about arithmetic sequences, but we're going to do it a little bit differently. So we're going to use this thing called Google Sheets, which is very similar to Excel spreadsheet, which is it's used a lot when you do anything used with spreadsheets. So usually with like budgets or anything to do with money, right? I know like when we're setting up a family budget, like we'll use Excel spreadsheet a lot. So this will be a good way to kind of do both, right? Very applicable, like put it on your resume if you know how to use this kind of thing, right? From what I teach you, feel free to try and experiment a few more things. Google Sheets will always, it's free, right? And you will always, will same as Excel for you guys, but it'll always save it, right? Because this is just doing it from online and also it'll always save. So you don't have to worry about that. So if you look right here, we have term number. We're going to number it. So instead of just I go 1, 2, 3, and make sure you push enter. If you don't push enter, it's not saving a thing. So what I would do here, instead of having to type out 4, 5, 6, so you're going to actually just highlight that. And then if you look at this little box on the lower right-hand side, this blue box, you hover your mouse over it so it turns into a plus, right? And then you're just going to drag it down. So just click on it, drag it down, and until you get to where you want to get to. So we're going to go until term 14. Okay, and somebody down here was doing some stuff. Don't mind those. And it says for number 2, it says given a sub 1 is 2. So that means that the 1 means that's the first term. So the first term is 2. So here you go, first term 2, enter, done. And then the common difference is 5, right? So I'm just going to write 5 here. I'll show you in a bit how to what is it called? How to figure that out if if it's not given to you. So we'll talk about that in a bit. And then if you look right here, number 2. So it says this is where we're going to put in the recursive formula. We know that if I just go 2 plus 5, that will give me 7. That's the next number, right? That's what the common difference means. We're adding 7 to that. So the recursive formula says, and the way you show Google Sheets that it's going to be a formula is you push the equal sign. So if you go equals, it'll automatically, you'll see it up here as well. This is the f of x. This is like your function notation here. So equals is the previous number, right? And if you look right here, the recursive is, this is, remember let's see if I can write this down. So this is, remember, the previous term. And it's not plus 2, that was for something else. The previous term plus the common difference. Okay, and notice the common difference is the thing that's going to change. There's my purple. So if you notice, the purple is the thing that changes. The green stays the same. It does not change. All right. And then so we're going to write that here. So the previous number is, notice right here, this is B. So this is this 2, the cell 2 is B2. Okay. It matches up. This is the column B, row 2. Okay. So it's like what is it called? Battleship. If you ever played Battleship a long time ago, if you haven't, I recommend that you try that. And then so we're just going to click on B2, right? Just like that. Notice that B2 comes up, and then we're going to add 5, because remember 5 is our common difference, right? And we're just going to push enter and see it's 7. It does the calculation for you. See, really cool. So what we're going to do is we want this formula to happen for every single one of these. So we're going to do, again, do not highlight the 2 and the 7, just the 7, because that's where the formula is, right? And then we're going to go over that the bottom right corner where the blue box is, hover over that, and we're going to just drag it down. All right, and if you see right here, see how it's all filled out? And if you notice right here is 7 plus 5, which is 12, 12 plus 5, which is 17, right? All calculations done, right? So that's going to be our recursive formula. So again, like our recursive formula for this one right here, let me just write it over here. Ooh, what with that? So recursive for us is going to be, so the way we write that is a sub n is equal to the previous term, the n minus 1, plus 5. That's what we would write. See, same, it's mismo. And then, so now So we completed the table and then use explicit formula to find a sub 49. So that means the 49th term. So we want, we're saying that this is going to be 49. Okay, we want to figure out what that formula is going to be. So so again, if we're putting in a formula, we need to say equals. So that indicates to Google Sheets that, hey, the program, right? Hey, we're going to be doing a formula now. So equals what? So here, the explicit formula right here on the left-hand side is going to be A1, which is the first term. We know the first term is 2, so we're going to type in 2. And then it says plus the D, which is the common difference, which is 5. So plus 5. And then here we actually need to specifically state that we're going to multiply, because this does not automatically assume that parentheses mean multiply, so they don't understand what that means. So we have to put parentheses though, and then it's going to be n minus 1. What is n? Is whatever this number is. Okay, so whatever's in this box is what we're going to plug in. So in this case, it's cell D3. So whatever D3 number is in D3, that's where they're going to input in there. But it's not just that, it's going to be minus 1 and parentheses. And then don't forget to push enter. And once you do that, look, 240. So we know that the 49th term is 242. We also, then we could see, well, what if if we don't want the 49th, we want the 200th term, right? So we go 200, press enter, and you see, like magic, it's 997. So automatically we know for any number that we want, we know how to get it. Any term that we want, we know how to get it. Okay, just by using the explicit formula. Do you see how cool that is? You have to do no calculations, right? But you got to be smart. You got to know how to do these formulas. Okay, and if you notice, I don't know if you guys noticed, but right when I put these in there, this little graph came up, and what do you know? Is it always going to be a line? I don't know. Let's find out. Okay, so that's number 2. And the way we write the explicit formula right here, explicit. So here's explicit. Oop, that I kind of. So explicit formula is never mind. Is again. So the green the green we leave alone. Okay, and it's the purple that we're going to change. So a sub n is equal to, it says A1, remember what did we say A1 was? 2, plus D, which is the common difference, which was 5, and then it's going to be n minus 1. Okay, and if you look at our equation right here, do you see how this looks exactly the same, except for instead of n, we put in D3, because it needs to know, we need to specify what that n is and where that's going to be. Okay, so for us, our variable is that D3. D3 is the variable. Okay, because why? Because n can change. It could be whatever number we want it to be. All right, so again, if you have not done this before, work on with me a couple of times. But if you have, you're like, okay, I got this, I was in class, let me try a couple by myself, then I would pause now. And well, not right now at the very moment, but do 3, right? And then go over and see if, and then you can skip over the part where the answer is for number 3. You can see if you got what I get, okay? And if not, then watch the video all the way through, or do both, I don't care. Okay, now you would pause for if you want to do 3. Okay, so now we're back. All right, so here is the A1 is 5, so that's our first term. So we're gonna, instead of 2, we're gonna put in 5 and push equals, or enter, I should say. We don't have an equal thing. And then notice all these changes, right? But that's not what we want, because we want the common difference to be 3. So instead of this being 5, we're just gonna go up here in this, the function place, and we're going to say the common difference is 3. So it's going to be plus 3 instead, and push enter. Now what we're going to do is we're going to override all the other ones. Okay, so we're going to just drag it down just like how we did before. And if you look right here, see, it changes, right? So the graph changes. Is it still linear? Yeah, it's still linear. And our common difference is now 3. Okay, remember, I'm going to show you how to find that out using a formula, just because it's cool like that. All right, and again, our explicit formula is going to be different because, oh, forgot to write this down. So for the explicit form, recursive formula, let's write this in green. So the recursive formula is going to be the previous, so is a sub n is equal to, right, just right here, the previous term, so a sub n minus 1 plus 3, because that's our common difference. So whatever the previous term was, plus 3. That's it. And so now we're going to find the explicit formula to find this 52nd term. Now you can certainly try and do it by yourself, like drag it all the way down and go to the 50s. You can, but what if I wanted 427th? Like, do you really want to do that? I mean, I guess if you want to, but I can find better ways to spend my time. All right, so here the explicit formula, just like what we wrote here. So a sub n is in green, so we're going to leave that as is equal to a sub 1, which is our first term, right, which is 5, plus d, which is our common difference, 3 times n minus 1. N minus 1, notice, is in green, which means that it is not going to change. And again, if I'm telling you to write me a formula and there are no variables in there, there are just numbers in there, that's not a formula. Okay, it's for a specific instance. I don't want a specific instance, I want a formula. Okay, and so that's the one that I can use for any term. And so if you look right in here, if let's say instead of this I put in a2, right, I'm gonna get an answer, but it has nothing to do with what this is. If I change to 111, see, 7 doesn't even matter, right? So you have to have this be this term right here. Okay, it has to be dependent on that, or else it's not going to be cool. Oh, did I do it? I didn't do it. I have to change this. I want to change this to be, oh, it won't let me do that. See, in Excel it does that. Okay, I'll just write in D3. There you go. Now it did it. So now remember, this formula was for the last one, so for number 2. So what we change in here is the 2, instead of the first term being 2, the first term is now 5. And now the common difference is not 5, it's 3, right? And those are the only things we need to change. Enter. Yay. Okay, but we don't want it for the 111th term. We want it for, what is it? 52nd term. So the 52nd term, enter. Okay, and remember, if you don't push enter, it won't know how to calculate it. It doesn't know like when to do that. So you got to push enter. And then so that is going to be, so I should have wrote down a sub 52 is equal to 158. All right, and again, line. And we'll try that for this one, for number 4. Again, if you just watch me doing it, you're not going to learn it as well as if you do it yourself. Just saying, so make sure you're doing that. So our first term is -4. Oh, just kidding, it's -2. Where did I get -4 from? So -2. Okay, and then so once we get to -2, and it says our common difference is 6, so I'm just going to write 6 here. No formula just yet, because I'm not there yet. Now let's see our recursive formula. Remember, our recursive formula is going to be in a different color, like blue. So recursive is going to be a sub n is equal to a sub n minus 1. It's exactly the same. And my common difference is 6. So plus 6. That's it. So again, we're going to write in here, instead of being plus 3, it's going to be plus 6. Right, now we're going to drag that down all the way to 14. You notice? And what do you notice about the line? Well, it's still a line, right? And our explicit formula, okay, now we want the 123rd term. All right, so let's do the explicit formula, which is going to be a sub n is equal to a1, which is -2, because that's our starting point, right? So we have our starting point, and then how many times are we going to add it? Add the common difference. It's going to be 6 times n minus 1 times. That's going to be here. The formula is going to be, so we're going to change the first term, which is now going to be not 5, but it's going to be -2. And instead of being 3, it's going to be 6. And everything else stays the same. And we want not the 52nd term, but we want the 123rd term, 1, 2, 3 term. So a sub 1, so the 123rd term is going to be, that's 3. It's going to be 730. It's not too bad. It's kind of big. There we go. So now we're going to change it up a little bit. What if we're given the table, right? Now we want to find the first term and the common difference, okay? Because we're not given that anymore. We're given a table. So what I'm going to do, I'm going to just erase this guy first. Keep me focused. Erase my common difference. Well, I'll leave those alone because it's going to be about the same. So our first, okay, so we have given this table. So this is N1. So this is going to be the first, okay, so we're given the first term. So here's 7, 9, 11, 13. You know, so many numbers, right? And so what we're trying to find, okay, we know the first term is 7. Okay, so we're going to be like, okay, A sub 1 is equal to 7. It's right here, first term. But we don't know the common difference. So here in the common difference, we're going to actually figure that out. So we're going to go equals. What does it equal? Well, you can honestly use any of them. So I'll use like this, the third term right here. But if I'm going to take the third term, I have to subtract it from the second term. Okay, it's not third term for the first term, or it just have to be right next to each other. Okay, so now B4 minus B3. So it's going to be 11 minus 9. Okay, whatever's in there. All right, I'm going to just enter that, and it's going to give me the common difference of 2, right? Which means we're adding 2 every single time. The reason why now we know why it's called a common difference is because the way we find it is we subtract the third term with the second term, or whatever the term is minus its previous term. Okay. So we know that our common difference is 2. Knowing this, we can write our recursive formula now. So what I'm going to do is I'm going to write it right here because I know what the number should be. So this is a good check, right? So I'm going to say equals the previous number plus 2. Yep, and it's 9, just like how we said. So the next 2 numbers should be 11 and 13, right? So I'm going to just drag that formula down. And what do you see? Yep, it is 11, 13. And notice it's all the odd numbers, right? So that's a good way to check you. All right, so there we go. So that is the recursive formula. So recursive is going to be the way we write that in longhand, I guess, is the previous term plus 2. That is the formula. Do you see how, like, we don't change a lot? The only thing we're changing is like literally just the last number, plus 2, or if it was subtracting, that'd be negative 2 or minus 2, right? But we're not subtracting. Okay, now the explicit formula. Again, it's going to be A sub n is equal to first term, 7, plus the common difference times n minus 1. The only thing I need to change really is going to be the first one, which is not going to be negative 2 anymore. We're starting at 7. And then we're going to go up by 2. Okay, and we're still subtracting n minus 1, right? And we don't want the 123rd term. We want the 38th term. So we're going to go 38, right? And it is 81. It is an odd number, which is what we're expecting, 81. So A sub 38 is equal to 81. Okie-dokies. And I think we found all the things we're supposed to. And then number 6, the last one. This is a little bit tricky. Okay, so now I'm going to erase these guys. Don't need them. And if we notice, okay, this starts with the third term. So we're going to go third term, and that's 22, 26, 30, 34. Okay, that's it. Oh, and if you look right here, they give us a number, but we're not, it says B4 minus B3. So we don't have that yet. So I don't know what the common difference. So let's change it. We're like, I don't know what to do then. So we're going to erase this and we're going to go equals. Okay, so because I don't have the second term, so let's go with the 6th term. 6th term minus the 5th term, which is going to be 4. That makes sense, right? Because it seems to go up by 4. Yep, totally works. Now, I don't know if you know. Actually, I don't know. I don't think I've tried. On Excel, it works. But if you drag it up, it should work the same. Oh, yep, see, it does. Works the same way. And we're going to drag it down. Happy days. Yay. And if you look right here on our graph, it is a straight line, which it should be. All arithmetic ones are straight lines. So happy days right there. So now we can figure out what the first term is, which is 14, right? Not much working going on. You know, it's good to be smart. And then here again, we're going to change the first thing right here. The first term is now 14, we know, because we couldn't write the explicit formula without the first term. And we know our common difference is 4, and it's still n minus 1. And so we don't want the 38th term, we want the 65th term. All right, so which would be 270. And if you notice right here, Oh, let me write this down. So a sub 1 is equal to 14. The common difference is 4 we found. And a sub 65 is equal to 270. So the 65th term is 270. And again, the formula is a sub n, this is recursive, is a sub n minus 1 plus 4. Previous term plus 4. The explicit formula is going to be wherever we're starting, right? We're starting at 14 plus the common difference. We're adding this how many times? N minus 1 times. Just like that. All right, so here's the questions. When you finish the table, what does an arithmetic sequence graph look like? A line. Usually it's going up, but what if it was negative? What if the common difference was a -4, right? So let's say right here, where did we start it? Where's my equation? It's gone. Okay, I don't know where my equation went, but let's put the equation in here. So equals, what did it equal again? The previous term plus, let's do minus. Let's do -4 this time. Okay, so now we're going to go, what's going to happen to the line? To see how it goes negative now? It's like going down in this downward slope, right? So it's a negative slope. The line has a negative slope, right? That is a negative slope, has this negative slope. All right, and so our common difference is -4. Notice right here remember how we had a formula in there and it automatically changed to -4, like it knew, right? If, cool. So if I change that to like -10, right? Enter, don't forget enter. And then I need to copy that down because it doesn't change the formulas down there. And look, oh, did I not do it? -10, drop down. There we go. And look right here, common difference, -10. What? It doesn't change the explicit formula because I didn't program it to be that way. Okay, now if you really wanted to, right? If you wanted to this be like all encompassing kind of thing, you could technically say instead of 14, you can just say, well, I want it to be whatever this first term is going to be. Okay, and then, I need to actually do this separately. So equals. So I could technically say, if I'm going to keep on using the sheet again, so I know the first term, right? It's always going to be there. And I'm going to add it with the common difference, which is right here. So common difference right here. So that's where I'm going to put my common difference. And I'm going to multiply that by this term -1. I mean, you can do it this way. So now all you need to do is change this one number, the sequence. Okay, I guess we need to change the common difference too. Because, okay, and let's say this is 5. Right, and see how my comments, see how this changes automatically. And if I want to just check to see if I did it right, this is what I like to. I go with the 6th one because I know the 6th term should be -45. That's what should come out. This is how I can check if my explicit formula works. I go equals -45. Well, what about for 14? Just in case. So here's my 14. -125. What? Yeah, it's pretty cool, right? What if I change it to? So honestly, if I want to just change this common difference to like 2 instead, let's put an enter, it'll change this automatically. That's what it won't change this automatically because I tried doing that. It doesn't work out very well because you're dragging things down. As soon as it's just one formula, but this drag down thing, it doesn't work like that. Recursive formula doesn't like stuff like that. So I tried, it didn't work. So yeah, so this one you'd have to do manually by hand, but if you go like +2, like this, and then drag that down, I mean, it's not overly tedious, I suppose. But I was just trying to simplify things down more. But yeah, see how it's pretty automatic. So 14 is 31, 14, 31, just like that. All right, and describe the recursive formula in your own words. What is a recursive formula? It's the previous term plus whatever the common difference is, whatever you keep on adding or subtracting, right? And describe the explicit formula in your own words. We start out with the first term and then add however many common differences we're going to do. We're going to add on to it, right? Remember, multiplied addition is just, or repeated addition is multiplication. So how many times are we going to add 4? 7 times. Then it's, that's what we would do. All right, so that's the meaning of that. Hopefully this was helpful to you. I will see you when I see you.